Hello students, in today's video we will be discussing about sets and the topics to be covered are Venn diagram and operation on sets. So Venn diagram. So what is Venn diagram? Venn diagrams are which represents the relationship between the sets. Suppose if we have two sets, the representation of sets in the diagrammatic form, that is called Venn diagram. Suppose considering set A so these are all representation of sets in the number system. I can keep, so these are all the ways of representing the sets. Suppose this is natural number, and this is whole number, and this is integer, and this is your rational number. So I can express this form in terms of the sets to be represented in the diagrammatic form. This is called Venn diagram. And now we'll be discussing about the operation of sets. So the operation of sets, we'll be discussing about union of sets, intersection of sets, difference of sets, complement of sets. So the symbols to be used, so one by one we'll be discussing. So first, what is union of set? So union of set, considering two sets, set A and set B, the union of two given sets A and B is a set which consists of those elements which are either in A or in B. Considering set A, so in representing in set builder forms, A union B, this is the denotion for union of two sets. A union B elements X such that X belongs to set A or X belongs to set B. This is the definition for union of sets. Example, shall we keep set A as 1, 2, 3 and set B as 3, 4, 5. Then what is A union B? So A union B is equals to the elements which are present in set A and in B. The elements which are repeated will be taken only once. So the elements in A union B will be 1, 2, 3, 4, 5. If you see, 3 is being repeated in both the sets, so it is written only in once. So A union B. So then we will be proceeding on in Venn diagram format. So what is Venn diagram format? Suppose this is your set A, set B, and then this is set A and set B. So to denote what is A union B is shading of A circle and your B part. This is the denotion for A union B. If suppose they are disjoint, considering these two circles, this is A and this is B. For this A union B, shading of both A circle and B circle. This is for disjoint and this is for they are having some common property. So these are the representation of a union of two sets using Venn diagram. So now we will proceed on to the next operation, that is intersection of two sets. So what is intersection of two sets? So the intersection of two sets A and B, in which the sets consist of those elements which belong to set A and set B. So this is what important, set A and set B. So to denote this in set builder form, this is the symbol to be used for intersection operation. A intersection B. So X such that the elements will be taken from set A and the elements will be taken from set B. So this is the property which shares both the elements present in both set A and set B. Considering an example, suppose set A is equals to 1, 2, 3 and set B is equals to 3, 4, 5. And what is A intersection B? So A intersection B means the elements present in set A and set B. Here 3 is there in both A and B. Therefore A intersection B, the elements which has the common or sharing of element from both set A and B. So this is what through examples we are defining what is the intersection of two sets. Now we'll be proving with the Venn diagram. Suppose set A, set B, and we have with they are not having a common property. So now to show what is A intersection B, what is A intersection B? A intersection B, the shading, this is your A circle and this is your set B. When we are shading the common thing, this is region, the shading region is termed as A intersection B. Suppose this is A and this is B, and to shade A intersection B, if they are not having any common thing, then we say A intersection B is an empty set. So this is through Venn diagram. Next we will be proceeding on to show what is called difference of two sets. So difference of two sets. So the difference of two sets A and B denoted by A minus B, A difference B. So that is the procedure to be said. A difference B is defined as a set of elements which belongs to set A but not to set B. To show by the example, so first through set builder form, the definition is X such that X belongs to set A provided X does not belongs to set B. This is what A difference B. Suppose the difference B difference A, that means X such that X belongs to B and X does not belongs to A. This is what B difference A. So we shall show this by example. Set A is 1, 2, 3 and set B is suppose 3, 4, 5. To write A difference B, the element which are present in A, it should not be present in B. Suppose 3 is there in B, we should not include 3 in A difference B. So the elements 1 and 2 are not belongs to B. Therefore the element in A difference B will be 1, 2. And what are the elements in B difference A? So those elements which are present in B should not be contained in A. So 3 is there in A, therefore except 3, we will be writing the elements 4 and 5 are in B difference A. So this is the example given for A difference B and B difference A. To prove this by Venn diagram, suppose this is your A and this is your B. To show this is A and this is B, to show what is A difference B will be the shading region, the property which satisfies, or A difference B means this is a region where B is sharing with A. So accept that when we are shading all this region, this is called A difference B. So that is another important property to be discussed. So that is A difference B. So in short, we will say this as A symmetric property. A del B is equals to A difference B union B difference A. So this is what another property, A delta B, symmetric property. Okay, now we'll be discussing about complement of a set. So what is called complement of a set? So let U be the universal set. So we discussed in the previous session what is called universal set. So let U be the universal set and A be a subset of U. Then the complement of set A is the set of all elements of U which are not the elements of set A. So by example or by set builder form, what is A complement? So that it is denoted as A dash, which is equals to X such that X belongs to the universal set and X does not belongs to set A. This is what the definition for universal set. So we can give by example. Suppose universal set be 1, 2, 3, 4, 5 and we are defining A as 1, 2 and now to write A complement, which is nothing but universal set difference A. So which is universal set element is 1, 2, 3, 4, 5. Set A has 1 and 2. The elements which are in universal set should not be contained in set A. So the elements which are not there are 3, 4, 5 are not in set A. Therefore, A complement is 3, 4, 5. How to represent in set builder? How to represent this in the Venn diagram? Suppose for Venn diagram, the universal set will be represented as a rectangular region, and this is your circle A, set A, and to represent this is your set A. To represent A dash, this is your universal set. So it is enough if we shade. This is A dash means other than A, when we are shading outside the set A, this is called A dash. So there are certain properties of complement of a set. So number 1, A universal union A dash, which is always universal set. Second property, A intersection, the operations A dash will leads to, because these two are disjoint set, will leads to empty set. And third property we'll be discussing about A complement of complement will leads to A itself. And then empty set complement will leads to universal set. Universal set complement will leads to empty set. And then few more properties that we'll be discussing here, that is De Morgan's law. So what is called De Morgan's law? So De Morgan's law is nothing but A union B the whole dash is nothing but A dash intersection B dash. This is one. And the second De Morgan's law is A intersection B the whole dash is A dash union B dash. So these are the very important laws to be proved in complement of a set. So next we will be discussing about